Right, now we go on to right-angled triangles. This is revision from last year. It's defining what an opposite and adjacent is. Notice the opposite is opposite the angle. Adjacent means next to the angle. If the angle's up the top here, then it swaps around. Opposite is still opposite. Next to is that one there. So work out which signs you are using depending on where the angle is. Now there's Sok Katoa, and here's some examples for you to try. So this is pretty straightforward. Find the length of the third side and hence find sine, cos and tan. Okay, so we want to find the unknown side x. So if we use Pythagoras, we'll be able to get that. So if we use 5 squared equals x squared plus 4 squared, then we'll be able to solve that. Now someone might have spotted that this is the 3, 4, 5 Pythagorean triad. We know it's going to be 3. If you didn't spot it, you would have to follow this process through. So we've got 25 equals x squared plus 16. 16 take over the other side, so you've got a minus 16. So 25 minus 16 is 9. And now you square root that. You have plus or minus 3, but because it's lengths, we only go with the positive version, so x is 3. Now that we've got the length of that side there, we can now work out what's asking for sine, cos and tan. So sine theta equals opposite over hypotenuse, which is 3 over 5. Cos theta equals adjacent over hypotenuse, which is 4 over 5. And tan theta equals opposite over adjacent, which is 3 over 4. And you do the same for B and C. So pause the video and try BC and maybe DEF and come back and look at the solutions. And here's the solutions to 1C, 1 A, B, C, D, E and F. Okay, the next question is, if theta is an acute angle, cos theta is a half, find sine and tan. To do that one, we write down cos theta equals a half, and we could draw a triangle because we know it's a right angle triangle. We know that cos theta equals half. That means because cos is adjacent over hypotenuse, then if we put theta there, that means the adjacent must be 1 and the hypotenuse is 2. It doesn't have to be like that because it's a ratio. We could actually put 2 there and 4 there. It's in the ratio of 1 is to 2. So, but because we're not finding actual lengths, it's only asking us to find other ratios, we can use this technique. So now to find sine theta, if we want sine theta, we want opposite over hypotenuse. Well, we don't know the opposite. We could call it x. To find x, use Pythagoras, and then we can get cos theta and tan theta. So we have 2 squared equals x squared plus 1 squared, and so 4 equals x squared plus 1. X squared equals 4, take 1. So x equals square root of 3. We only take the positive version. So sine theta equals opposite over hypotenuse, root 3 on 2. And the tan, I think was asking for tan, yep, tan theta equals opposite over adjacent. Okay, just pause the video and you can do part B and C and come back and check the solutions. And here are the solutions, part B and part C. Question 3 is now about complementary angles. We did supplementary angles not long ago. Complementary angles are angles that add up to 90 degrees. So this is using unknowns or letters, not numbers. So we have A, B, C, theta and 90 degrees. It says first of all to find sine theta. Now sine theta equals opposite over hypotenuse, so that's A on B. Cos theta equals adjacent over hypotenuse, so that's C on B. Sine of 90 take theta. Now 90 take theta is the angle sitting up here, 90 minus theta. Because when you add these two together, they give 90, and 90 plus 90 is 180. So this is 90 take theta in here. So the sine of that, you've got now the opposite is C. So opposite is C, sine 90 take theta is C over B, opposite over hypotenuse. And we can see it gets the same answer as this one here. So cos theta actually is the same as sine of 90 take theta. Likewise, we can do the cos of 90 take theta, and the cos value is adjacent over hypotenuse, so it's A over B, and that answer is the same as sine of theta. So we can now come up with a rule. It says use your results to finish off this sentence. The sine of an angle is the cosine of its complementary angle, and the cosine of an angle is the sine of its complementary angle. Now question 4, we need to do, for this isosceles triangle, need to do sine, cos and tan of 45. Okay, so we'll just do the drawing. So we have an isosceles triangle 1, 1, 90, 45, 45. And we're going to work out sine, cos and tan. Now if we do the Pythagoras rule, just to work out what the hypotenuse is, we have x squared equals 1 squared plus 1 squared. So x squared equals 1 plus 1, which is 2. So x equals plus or minus root 2. We use the positive value. Now we can work out sine 45. Sine 45 equals opposite over hypotenuse, which is 1 over x, which equals 1 on root 2. Now that is approximately equal to 0.707. We're going to be referring to these often, so we actually want to remember this off by heart, 1 on root 2. Now cos of 45 equals adjacent over hypotenuse, so that's going to be, if you look at this 45, adjacent is 1 also, so it's also 1 over x, so it's going to give the same answer. So also 0.707. And tan 45 is going to be sine 45 divided by cos 45. Now sine 45 is 1 on root 2. Cos 45 is 1 on root 2. When you divide those two, when you divide two fractions, you've got to invert multiply. So it's 1 on root 2 times by the bottom fraction has to be flipped upside down, root 2 on 1, and so the root 2's cancel, and so your answer is 1. So tan 45 is 1. Okay, now question 5 is looking at an equilateral triangle. We're going to draw the triangle in. So 5, part A, we have equilateral triangle, all with sides 2, and perpendicular bisector coming down, splitting that in half and splitting the angle in half. Right, the first question is find the measure of angle ABN and BAN. So we write it like this: angle ABN is equal to, so that's A, that's B, and that's N. So ABN is this angle in here. Because it's equilateral, that's 60 degrees. And angle BAN, that is BAN, is this angle sitting in here. Because the whole thing is 60, that's half of 60, so that's going to be 30 degrees. And this one down here is 90. In part B, it asks for the length of BN. Now BN is going to be 1 because it is half of the whole base, which is 2. And AN, which is the perpendicular height, we don't know what that is, we'll call that x. Now to work out x, we can use Pythagoras, where we have 2 squared equals 1 squared plus x squared. 2 squared is 4, 1 squared is 1. We now take 1 over the other side, 4 take 1 is 3. And if you square root that, we have x being root 3. So AN equals root 3. Now part C is asking for sine, cos and tan. Now to do that, we only have to look at half of the triangle because we need to do sine, cos, tan for a right angled triangle. So we're going to be looking at this one here. So just for neatness, I'll draw just that one again for part C. So doing the left hand side only, we have a triangle looking like this. This here is 2, this is 1, that there was 60 degrees, and that up there was 30 degrees. And we just worked out that to be root 3. Now part 1 is to work out sine 60. Sine 60 equals opposite over hypotenuse. Opposite that angle is root 3. The hypotenuse is 2, so it's root 3 on 2. To do cos 60, we do the adjacent to 60, which is 1, and divide by hypotenuse, which is 2. To do tan 60, we can do opposite over adjacent, which is the 1 over the root 3. And then in part 2, we can do the 30 degrees. So sine of 30, this time we're using this angle up here. This time the opposite is 1, so it's opposite over hypotenuse, so that's a half. Cos of 30 equals adjacent over hypotenuse, which is root 3 over 2. And tan 30 equals opposite over adjacent, which is 1 over root 3. Now these answers are all summarised below in this table. So we can see that sine 30 is a half, cos 30 is root 3 on 2, tan 30 is 1 on root 3. If we take the 60, sine 60 is root 3 on 2, cos 60 is a half, etc. And you can look back at all the questions above in 1B1 and 1B2, and it's all summarised in that table. Next lesson we'll use this table and relate it to the unit circle.